Alright, so streaming has started and we will also begin. So in the last session, we have kind of talked about what is ordinary differential equation. Firstly, we started with what is differential equation, and then we have seen couple of examples, and then we talked about first order linear ODE and its general form and how to solve those, like the solution to first order linear ODE. And we have seen different cases, and finally we have understood how to solve each and every case, right? And then we moved on to second order linear ODEs with constant coefficients only. So we are not dealing with any functions attached with f of x or its derivatives. Okay, so again, to motivate, we have started with an example. And then we have seen the general form of second order linear ODEs with constant coefficients. And we have also said that this is not, this doesn't have any straightforward method. We have to guess the solutions based on looking at the right hand side, q of x. And we have started talking about the homogeneous case where q of x is 0. Right, so if the q of x is 0, we guess that the solution is actually e power sx. And once f of x is e power sx, we compute f prime of x, f double prime of x, and substitute them and see to find the value of s. And once we substitute, we see that it boils down to a quadratic expression in terms of s. Right, so that quadratic equation can have a distinct real roots, two real roots, or one real root which is repeated twice, or it may not have any real roots. It can have complex roots. Right, so among the three different possible cases, we have seen the distinct real roots case, where once you find the solution to the quadratic equation, we get two distinct roots, s1 and s2, where s1 is not equals to s2. That is how they are distinct. Now once e power s1x and e power s2x are solutions, any linear combination of these two will also become a solution, or also the solutions for the ODE. Therefore, the general form of the solution will look like this. F of x is equals to c1 into e power s1x plus c2 into e power s2x. This is when we have distinct real roots. Right? So if your roots are distinct, only then your general form will look like this. F of x is equals to c1 e power s1x plus c2 into e power s2x. Okay, so where c1, c2 are still unknown, and we have seen one example to find c1 and c2 also. Right, so this is the example we have seen. We have been given the ODE, second order ODE, and with some initial conditions. F of 0 is equals to f prime of 0 is equals to 1. So from this given ordinary differential equation, second order differential equation, we have constructed the auxiliary equation. So that is what it is. This is a quadratic. Right. So after getting this quadratic equation, we solved that quadratic equation and we got two distinct real roots, 2 and 4. And the general solution will look like this, where still C1 and C2 are unknown. But using these initial conditions, we have substituted the initial conditions and we got two equations in terms of C1 and C2. So it's a system of linear equations and we know how to solve them. And after solving them, we get C1 and C2. And finally, if we substitute, our solution will look like this. Okay. So that's about the homogeneous with distinct real roots. What if the real roots are repeated? So form quadratic equation has the same real roots, where I mean S1 and S1 itself, you get the same real root. Okay. So when do you get the same real root? If the left hand side is a perfect square, right? So left hand side will just be some a times of s minus s1 whole square is equals to 0. Right? So when you have this kind of expression, you can also remove a. Right? You will have something like s minus s1 whole square is equals to 0. Then you will have two roots s1 and s1. Right? So that is what it is. So the left hand side is a perfect square, that you have to remember. I will tell you why that is important within 2 minutes. But if you have the repeated roots, how does your solution look? So the first solution will always be e power s1x, right? Because s1 is the solution for our quadratic equation. So e power s1x is e power sx is our guess. So I have to substitute s1 in place of s. That will be my first solution. Now this is the property. What this property says is, if you have the repeated roots, real repeated roots, then x into e power s1x will also be another solution. Along with e power s1x, x into e power s1x will also be a solution. Once you have these two, any linear combination of these two will also be a solution. Right? So therefore the general solution will be of this form now. What is the form? Form will be c1 e power s1x plus c2 into x into e power s1x. Right? So I have also written down why x into e power s1x will be a solution. Right? So I will quickly go through it. So I hope e power s1x is clear, because if you substitute, you will get that a s1 square plus b s1 plus c is equals to 0. So that is what it means. As if s1 is a root of this equation, then if I substitute, it should satisfy, right? So a s1 square plus b s1 plus c is equals to 0. Not only this is a repeated root. Okay, so even if I derivate with respect to s on the left hand side and the right hand side, still s1 be a solution, right? Because the arithmetic, the algebraic multiplicity of s1 will be, geometric multiplicity will also be 2, right? So therefore, if you derivate this and then substitute s1 also, you will get 0, which I mean this. So if I derivate this with respect to s, I will have 2a s1 plus b is equals to 0. So s1 will satisfy these two conditions. Okay, as1 square plus bs1 plus c will be 0. Along with that, 2as1 plus b is equals to 0, because s1 is a repeated root. Okay. So once you have these two things, now you will see that x into e power s1x will also be a solution to our differential equation, because if f of x is this, f prime of x will be this, right? Then f double prime of x will be this, x s1 square into e power s1x plus 2s1 into e power s1x. So you can solve this. After that, you just substitute them in our ODE. Okay, a f double prime x plus b f prime x plus c f of x is equals to 0. So if you substitute all these three things in this equation, you will see that we'll get these terms is equals to 0. And if I group the terms by x e power s1x, if I take common from this term, and this term, if I pull out x e power s1x, I'll have a s1 square plus b s1 plus c into x e power s1x. And from these two, if I pull out e power s1x, I'll have 2a s1 plus b. Okay. So this a s1 square plus b s1 plus c and 2a s1 plus b, both are equals to 0, because s1 is the root of this particular quadratic equation. Okay. So using these two, the left hand side will become 0, and which matches with our right hand side, which implies that our x into e power s1x will also be a solution along with e power s1x. So finally, the general solution when we have the repeated real roots is different from the general solution of distinct real roots, right? So if you see here, the general solution is C1 e power S1x plus C2 into e power S2x. That's it. Okay, so you'll have e power S1 which is different, and the second term will have e power S2 which is different. Whereas if you have repeated real roots, the general solution will be C1 into e power S1 x plus C2 into x into e power S1 x. Okay, so that is the difference. And again, how do I find C1 and C2 here also? The same, using the initial conditions. Okay, so here is the example. Let's say the second order ODE is given like this. So from this, if you form auxiliary equation, you will have s square minus 6x plus 6s plus 9 is equals to 0. And if you look at it carefully, the roots of this quadratic equation will be 3 and 3. So it will have only one real root which is repeated twice. Right? Once it is repeating twice, then your general form will look like this: C1 e power 3x plus C2 x into e power 3x. Right? So now we have to find C1 and C2. How will I find C1 and C2? I will use these conditions. F of 0 is equals to f prime of 0 is equals to 1. Okay, so if I substitute f of x is equals to 0 in this equation, I'll have f of 0 on the left side, and this will go to 0 because there is x here. So you'll have C1. So f of 0 is equals to C1, which is equals to 1. Okay, so from there you'll get C1 directly, and you derivate this particular equation and then substitute x is equals to 0. You will see that you will get f prime of 0 to be equals to 3c1 plus c2, and we know f prime of 0 is 1. So 3c1 plus c2 will be 1. As c1 is 1, if you substitute it here, you will get c2 to be minus 2. Therefore, the final solution will look like this. So 1 minus 2x into e power 3x. Okay, so you just have to substitute c1 and c2 values. Alright, so the only difference comes with the form of the general solution. Okay, so even in the third case also, that will be the difference. So if I have complex conjugate roots, which means if I don't have a real root, if I try to solve the quadratic equation, if I'm getting a complex roots, then always the complex roots will be conjugate pairs in conjugate. Right? So if one root is r plus it, another root will be r minus it. Okay, so here also the guess will be e power sx only, and so we substitute it and we get this auxiliary equation, which is as square plus bs plus c is equals to 0, which is again a quadratic equation, but the only change will be if I find the roots of this quadratic equation, I will have the complex conjugate roots, which is r plus it and r minus it. So therefore the solutions will be e power r plus it of x, e power r minus it of x. So e power r plus it of x, I can rewrite it as e power rx into e power itx, right? So and e power I something, I know how to expand it, right? Using Euler's formula, right? E power I theta, I can write it as cos theta plus I sin theta. So if I do the same thing here, we will get e power rx into cos tx plus I e power rx into sin tx. And the second solution will be e power rx into cos tx minus I e power rx into sin tx. Both the solutions are some linear combinations of e power rx cos tx and e power rx sin tx. Right? Therefore, what we say is by linear combination property or whatever, but the solutions will be the linear combinations of e power rx cos tx and e power rx sin tx. Okay, so therefore the general solution in this case will be of this form. Okay, so C1 into e power Rx into cos Tx plus C2 into e power Rx into sin Tx. And if you pull out e power Rx, you will have e power Rx into C1 cos Tx plus C2 sin Tx. Alright, so the general form only will change. So in all three cases, the general forms will change. The solutions general form will change. Everything else is different. The first step will always be finding the roots of this quadratic equation. If you get distinct roots, you will have one general solution. If you get one real root which is repeated twice, you will have some other form. If you get a complex conjugate roots like this, you will have this form. After this, again there will be C1 and C2 you have to find. How do we find C1 and C2? Again using the initial conditions which will be given to us. We will use those initial conditions and solve for C1 and C2 and substitute them back. Okay. So again, here is the example for the third case also. So you have been given the second order ODE, and with that we form this quadratic equation in terms of s. We'll get s square minus 5s plus 8 is equals to 0. If I solve, I'll get roots to be 5 plus square root 7i by 2, 5 minus square root 7i by 2. So this is a complex conjugate roots case. Right? Therefore, the general form will be here r is 5 by 2, right? T is root 7 by 2. Right? So you see r plus I, if r plus id is the root, your general form will be e power rx and cos t sin t. Okay. So therefore, the general solution will be f of x is equals to e power 5 by 2x, which is r, 5 by 2 is the r, into c1 cos root 7 by 2, which is the t, x plus c2 sin root 7 by 2 x. Okay. And we have the initial conditions here given. So substitute x is equals to 0. If you substitute x is equals to 0, this will vanish because sin 0 is 0. Cos 0 is 1. And e power 0 will be 1. So you will have f of 0 to be c1, which is equals to 1. Similarly, I derivate this and then substitute x is equals to 0 to get the other constant, which is c2. We will get, if you do that, you will get c2 to be minus 3 by root 7. And what you have to do, you just have to substitute them back in the general form. You will get the final solution for our second order ODE. Alright. Any doubt so far in homogeneous case? See, homogeneous case, if you understand homogeneous case, then you will be able to solve, or you will be able to get some 3-4 marks in your enter. Okay. So the only thing is you have to identify whether you are getting distinct roots, or are you getting repeated real roots, or you are getting complex conjugate roots. In all three cases, you should know how to write the general form, and then you should also know how to get those unknown constants which are C1 and C2. Okay. Any doubts? If you guys have any doubts, you can ask me. Okay, then is this clear? So how to understand I imaginary value of sine and cos? I didn't get your question, Akhil. Can you rephrase that? Or can you unmute and ask? So is your question related to this Euler's formula by any chance? Okay, so that's a different altogether discussion. So you are asking me how do I interpret this? Yes. Okay. Okay. So this is okay. Let's do one thing. I will not. I don't want to break the flow of week 12. Okay. So if time permits at the end, we will discuss. We will have a discussion on this. Okay. Yeah. All right. So any doubts related to the process, how to solve ODEs, second order ODE in all three different cases? Okay. So moving on. Let's talk about non-homogeneous case also. So far we have discussed only the homogeneous case where our q of x is 0. So the right side q of x is 0. Non-homogeneous case, q of x may not be 0. Q of x can be a constant or q of x can be any function of x also. Okay, so this right side, this one, right? So in these cases, in non-homogeneous cases, what we finally write as a solution is the solution will be broken down into two terms. The first term will be the solution for our non-homogeneous case only, and the second term will be called as particular solution, which will be added to the non-homogeneous solution. So this is a property. Okay, so this is a standard property. So if you have a solution g of x for this particular given second order ODE, okay, and you have h of x to be your homogeneous case solution. Okay, so you keep q of x to be 0 and solve for the homogeneous case and you will have a solution h of x. Okay, and g of x will be the solution for the given by taking q of x to be as q of x. Then if you add these two, g of x and h of x will be a solution to this particular second order ODE. Okay, and you can also see that our h of x will make, even though you take it, will make the right hand side to be 0. So this will become 0. So even if you add g of x plus h of x as the solution and you take the derivative and double derivative, you will see that a h double prime of x plus b h prime of x plus c h prime of x will become 0. Okay, finally you will get the same thing. Okay, so the homogeneous solution should also be considered. Or in other words, it should be added to the general solution also. Okay, so this general solution is called the particular solution. Okay, so g of x is called the particular solution and h of x is the solution for our homogeneous equation. Okay, so we can find h of x, but we are yet to know how to find g of x, which is the particular solution. Okay, so here also we will guess the particular solution and we primarily have only two cases here. Okay, so either our q of x is a constant. Okay, for q of x is a constant value d, then our guess will be a constant value. Okay, or if our q of x is some combination of sinusoids like u sin x plus v cos x, our guess will also be some r sin x plus s cos x. Okay, so if our q of x is a constant, we will guess our solution to be constant. If q of x is some linear combination of sines and causes, our guess will also be the linear combination of sines and causes. Okay, so once you have this guess, we did this previously also, right? So once we have f of x, we can find f prime of x, we can find f double prime of x and then substitute it here. Okay, so for example, if we have a second order ODE, non-homogeneous case, the right hand side is 4. Okay, if the right hand side is 4, our guess is another constant which is E. Okay, so once we have f of x to be E, f prime of x will be 0 because f of x is a constant. So if I derivate a constant, it will give me 0. And f double prime of x will also be 0. Right, so if I substitute these three things, I will have 0 plus 5 times E is equals to 4. Right, so 5 times E is equals to 4 or E is equals to 4 by 5. So our solution will be 4 by 5. This is the particular solution. So 4 by 5, the general solution will be 4 by 5 plus you have to find the h of x, where h of x is the homogeneous case. Homogeneous solution. And just now we discussed, right? So how to find homogeneous solution? You have to equate this to 0 and then form the quadratic equation and then solve for the roots of the quadratic equation and see if they are distinct. Then you will see distinct real. Then you will have one kind of form. If it is real repeated, it will have one kind of form. If it is complex, it will have some other kind. Okay. So that is this example. Here also, if I have some sin x or something. Okay, so here q of x is sin x here. So our guess will also be r sin x plus s cos x, right? So once our f of x is r sin x plus f cos x, s cos x, then f prime of x will be r cos x minus s sin x, right? F double prime will be minus r sin x minus s cos x, right? So that is what here substituted. F double prime of x, I will substitute minus r sin x minus s cos x plus 2 times r cos x minus s sin x, right? Plus 5 times f of x is r sin x plus s cos x is equals to sin x. Okay. So left hand side, if you simplify and compare the coefficients, okay. So you have sin x here. You will also have some r's and s combinations of sin x, right? And you don't have any cos x term here. So therefore the coefficient of this cos x term on the left hand side should be 0. So you will have 4r minus 2s to be 1, 2r plus 4s to be 0. Okay, so if I have to write down, so minus r sin x minus 2s sin x, 5r sin x, right? So minus r minus 2s plus 5r sin x plus, so here minus s 2r 5s, right? So minus s plus 2r plus 5s cos x is equals to sin x. So the right hand side sin x coefficient is 1 and the left hand side sin x coefficient is 4r minus 2s. Both should be equal. So 4r minus 2s is equals to 1. The right hand side cos x coefficient is 0. The left hand side cos x coefficient is 4s plus 2r. So 2r plus 4s should be 0. So those are the two equations here. And we will solve for r and s. You will see that you will get r to be 1 by 5 and s to be minus 1 by 10. You just have to substitute them. And this is the particular solution. Okay, don't forget. This is the particular solution and you have to add the homogeneous solution to this also for the general solution. Okay. So that is about the non-homogeneous case. But for examination point of view, homogeneous case is very, very important compared to non-homogeneous case. So non-homogeneous case takes some time because you have to solve for this particular solution and also you have to solve for the homogeneous solution and then add them together to get the final solution. Okay, it's a bit time taking. If you see any question of non-homogeneous case in the end term, then it means that there is some shorter or smart way to do it. Or we will give you the particular solution, or you just have to find the homogeneous solution, or we will give you the homogeneous solution and you just have to find the particular solution. Okay, so the question will be like that. So you will not be asked to find both together. Rather, we will give you one and you have to find the other one and then give us the final solution. Or if we didn't give anything, that implies that there is a shorter version to do it, or the guesses that you make, right? So here the guesses could be fairly straightforward. It won't be too difficult to guess. Okay, so that's about non-homogeneous case. Okay, so again in week 12, you should understand what the differential equation is, and you should really appreciate where all this differential equations are used, and you should know the solution to first order linear ODE completely. Okay, all possible cases. Okay, so you should be able to solve any given first order linear ODE. And then even in the second order also, you should be able to solve the second order homogeneous constant coefficients case. Okay, so this is the general form where q of x is 0 becomes our homogeneous case. You should know how to solve it. And also when q of x is at least constant or some linear combinations of sine and cos. Okay. When q of x is these two, you know how to find the particular solution also. Okay. So you will not see any other forms. Okay. So q of x we won't give you like e power sx into cos 2x or something. Okay. So it won't be like that. All right. So let's solve few problems. Any doubt in theory? You can let me know, or else we'll move to the problems. Okay, so today I just discussed the repeated real roots case and complex conjugate roots case, and then non-homogeneous case of second order linear ODE. Okay, so let's solve few problems then. Okay, so treat this like a solve with us session too. Okay, so I'll give you some time to solve and I'll create a poll. So once you have solved the problem, you can answer it in the poll. Then after 2 to 3 minutes or the time I have given for that particular question is done, we will discuss the solution. Alright, so we'll start with the first problem. Which of the following differentiable equations these are linear? Okay, so you have been given 4 options. And remember, the font is not directly proportional to the solution. Bigger font doesn't mean that it has high chance. Okay, so I'll give some 2 to 3 minutes for this. Meanwhile, I will create the poll. Alright, so I have created a poll. Once you have solved this, you can answer via poll. Okay, okay. So answer it like which of the following differential equations these are not linear. Okay, so I will give you the hint. So among the four options given, only one is not linear. All three, other three, sorry, sorry. Okay, so two are non-linear and two are linear. So at least give me one linear. It's fine. So choose at least one of the option. Okay, so if you think A, B are correct, you just choose A or B. Okay, so the question is which of the following differential equations are linear? Okay. All right, so I don't think this will require to more than 3 minutes. Let's see. Any answers from anyone? Option A, is this a linear differential equation? You can type if you don't like to unmute and talk. Anybody? Okay, so what is the general form of a linear differential equation? It will be of this form, right? So f some k times differentiated. Some function pk of x multiplied by fk and pk minus 1 x k minus 1 and so on plus p1x f prime of x plus p naught of x f of x is equals to some q of x. Right, so this will be the general form of a linear differential equation of kth order. So kth order also we discussed in the last session. So why kth order? The highest differential term that is there in this particular expression is f differentiated k times. Right, so therefore the order will be k, but that's not the story. The main thing is, in order to be linear, all the powers of this, right? So all the powers of its function f of x as well as its derivatives should be 1. The power should be 1. Okay, so this is power 1, this is power 1, this is also power 1, this is also power 1. Right? So this is linear. What are non-linear? If I have something like this, so f triple prime of x whole square, something like this, f of x whole cube, or f prime of x getting multiplied with f of x. So even here the order is 2, not order, power is 2, right? So f of x getting f prime of x getting multiplied with f of x, and what else? So like this. So these are, if you see these kind of terms, these are non-linear or not linear. Okay, so with that, I think we can see here option A will exactly follow our linear case. So this is linear. Option B, you see here 1 plus f of x whole into f of x. If you expand this, you will see that f of x whole square. Right, so when f of x whole square comes in, it becomes non-linear. Okay, so this is not linear. And even option C also, you see f double prime of x gets multiplied with f prime of x, and f double prime of x gets multiplied with f of x, which is not like in our general case, general form, right? So in general form, f double prime is one different term, f prime of x is another different term. So there is no mix up. So here there is a mix up, which makes this not linear. This will also be not linear. What happens to option D? Option D will have 3f prime of x minus x square plus x whole into f of x is equals to 0. So if you see 3 is p1x, x square plus x is minus x square minus x is p naught x. Every other pk's are zeros and q of x is also 0. So it is a linear. Or simply you see this. The power of f prime of x is 1. Power of f of x is also 1. Therefore, it will be a linear. Okay, so this is linear. So option A and D are correct if the question is for linear, and B and C are wrong. If they are asked which of the following differential equations are not linear, then it would have been option B and C. Okay, so just look at what they are asking for. Okay.
Sir, will you please repeat how option C is not a linear?
So option C is not linear because if I expand option C, this will have f double prime of x getting multiplied with f prime of x plus f double prime of x getting multiplied with f of x is equals to 0. Right? So here, this particular thing, this has power 1, this has power 1. Both are belonging to this f of x only, right? So this is some variable, this is another variable. Two variables getting multiplied will no longer be linear, right? So linear means if I say x1, x2, x3, xn are linear, or their linear combination will be linear combination will be ax1 plus bx2 plus cx3 and so on plus nxn, right? So some nxn. So what I say is this is the linear combination. If I have something like x1 x2 plus x3 x5, so if I have this is not a linear combination, right? So this is a linear combination, this is not a linear combination. Or in other words, x1 and x2 Okay, so is my voice too low?
Yes, sir.
Okay. Okay, so let me be a little louder. Okay, so if I have n variables and if I say the linear combination of those n variables, the linear combination will be like this: some constant with the first variable plus some constant with the second variable. So here in differential equations case, if I have to say a differential equation is linear, it has to be linear with respect to f of x. It should be a linear combination of f of x and its derivatives. So its derivatives are f prime of x, f double prime of x, f k minus 1 time derivative and kth derivative. So you treat these as the variables and any linear combination of this will give you a linear ODE. Any mix up, something like product uh, between two derivatives or product between the derivatives and the function will no longer be a linear. Okay, so it will be like this form. So these are not linear combinations. So linear combination will always have this kind of form. Okay, so that means your general form for a linear ODE should be of this form. So here you don't have any term where you have f double prime and f of x coming in the same term, right? So f of x will only be in this particular term. You will not have f of x in any other term. Same like f prime of x also. F prime of x will also appear only once, right? But here, if you see f of x and f double prime of x, this term is having both together, which makes it non-linear. So option C, that is why it is non-linear. Okay. Okay. Great. Let's do the second problem. And this requires some time. And this thing we have discussed in the last session also. But the case that we discussed was the ball is apple is falling downwards. Okay, so here the ball is hit upwards. Okay, so a ball is hit straight up with the initial velocity of 4 meter per second. So this is important. The mass of the ball is 0.08 kg. The air resistance on the ball is 0.5 v, where v represents the velocity of the ball at time t. Assume g to be, so this is the air resistance and this is the mass of the ball. Okay, and assume g to be 10 meter per second. Form a first order linear differential equations with initial conditions to solve for v of t. Okay, so let me start the solution, but I will not finish it. And you guys try it out. So you have a ball and it is straight, it is hit straight up. So the ball is moving upwards. Okay. So when the ball is moving upwards, the air resistance will act downwards. Right. So this is how air will resist the ball. Right. So that is how ball will stop quicker. Right. So the air resistance will act downwards, which is 0.5 V. And it's a ball, so it has some weight. And this mg acts downwards. Right. So this is the downwards force. Right. So these are the two forces. and the ball is moving upwards, right? So it is moving upward. And since it has some velocity, it moves upwards with some, it is hit, right? So with some force, initial force will be there, which is ma, where a is acceleration is derivative of velocity or the speed, right? So now this is the setup. You have to form the first order linear differential equation, and also you have to use the initial conditions. So somehow you have to, it is given in the question itself, so you just have to write them. Okay, so after writing them, you have to solve for v of t also. Okay, so take some 3 to 5 minutes maybe. All right. So a couple of questions. So yeah, in physics, units and dimensions are important, but here we kind of ignore. So 95% of the cases we don't deal with units much. Okay, so units are just for our reference. Okay, so we just have to tell you that it's not initial velocity of 4 kg, it's actually 4 meter per second, something like that. That's it. And yeah, so a couple of you gave the answers also, but let's see. So ball is moving upwards. So ball's direction is in the upwards, and the forces that acts in in that direction will be positive, and the forces that act in the negative direction will be negative. Opposite direction will be negative, and the total force should be zero. Right. So what we will have is m v prime of t, m v prime of t, and or m v prime of t should be equals to, these two are acting in the negative direction, right, or opposite directions. So this will be equals to minus 0.5 v minus mg, right? So when the ball falling, when apple falling downwards, what do we have? When the apple is falling downwards, the apple direction is also downwards, right? So the weight acting will be downwards, which is mg, and the air resistance is acting upwards, which is kVt. So therefore, the total force acting on the apple will be mg minus kVt, should be mv prime t. Right here also, so this is the total force that is acting. Right, so the total force will be 0.5 v plus mg, but in the opposite direction of the ball. Ball is moving upwards, and these forces are acting downwards. Right, so therefore mv prime of t, which is the total force ma, should be minus 0.5 v minus mg. If I rewrite this, this will be m v prime of t plus 0.5 v of t is equals to minus mg. If I divide m throughout the equation, we will have v prime of t plus 0.5 by m v of t is equals to minus g. Okay, so m is also given to us, which is 0.08. If you just substitute, you will have v prime of t plus 0.5 by 0.08 v of t is equals to, g is also to be assumed minus 10. Right, so we'll have this. All right, so now you just have to simplify this. We'll have v prime of t to be, sorry, v prime of t plus, this will be 50 by 8 v of t is equals to minus 10, or you can bring that 10 to the left side. This is the first order linear differential equation, right? And also, what is the initial condition? We need to write down the initial condition also. So the initial condition will come from here. It has an initial velocity of 4 meter per second. So that means at time t is equals to 0, initially the time is 0. At time t is equals to 0, we have 4 meter per second velocity or the speed, which implies that v of 0 is actually equals to 4. Okay, so this and this together is our first order linear ODE with initial conditions. Okay, so the first part is done. Now we have to solve for V of t. So how do we solve for V of t? You know how to solve it, right? We will use this. So this is the general form, we know, right? So P of x and Q of x are known to us. And if we have P of t to be some constant and Q of t is also constant, then we know how to write down the solution, right? So both are constants. So when P is constant majorly, we know how to write it. We will use that and we will finally get, so we'll use that now. So V prime of t plus 50 by 8, or in other words, I can write this as 25 by 4 V of t is equals to minus 10, right? So this is P of t, this is Q of t, right? So now I will take Q of t into, that is what I have to do, right? So e power pt into Q of t's antiderivative. So the antiderivative of e power 25t by 4 into minus 10. Okay, so the antiderivative will be minus 10 e power 25 by 4 whole divided by 25 by 4. Right, so that will be the antiderivative. That will be the first step. Right, finding the antiderivative. So once you have the antiderivative, you write with the general form. So the general form will be e power minus px into the antiderivative plus c into e power minus px. So once we have the antiderivative, v of t will be e power minus px. Right, so p is 25t by 4, 25 by 4 into t into the antiderivative of this. This will be minus 10 into 4 by 25 into e power 25 by 25t by 4 plus, right, so plus c into e power minus px. Okay, so if I simplify this, I'll have minus 40 by 25, which is minus 8 by 5 plus c into e power minus 25 c into e power minus 25 by 25t by 4. Okay, so this is v of t. Once you have this v of t and c is unknown to us, but we can use the initial condition, right? So initial condition v of 0 is 4. So you just have to substitute t is equals to 0. You will have 4 is equals to minus 8 by 5. What I did is substitute t is equals to 0. Substitute t is equals to 0. You will have 4 is equals to minus 8 by 5 plus c. From here you will have c to be 28 by 5. Okay, so you can solve it. You get c is equals to 28 by 5. And finally, v of t will be 28 by 5 e power minus 25t by 4 minus 8 by 5. Okay, so this will be 4 by 5 of 7 into e power minus 25t by 4 minus 2. Okay, so this will be the speed at time t, or the solution to our linear ODE. Once we have this solution, part 2 can be, they can ask the speed at any given time. Okay, so the question is, use the information in question to find the speed at 0.1 second. So if I have to find the speed at 0.1 second, I just have to substitute t is equals to 0.1, right? So v of 0.1 will be 4 by 5, 7 into e power minus 25 into 0.1 by 4 minus 2. Okay, so solve this and you'll get an approximate value for this. Okay. But what we have used, the concept that we have used is this. So after forming the first order linear ODE, the first and foremost thing is to identify our P of t or P of x or Q of x. Once you have that, you have to find the antiderivative of e power px into Q of x. Right? And once you get that, you write down the general solution, general form, and substitute the values. Okay. And after that, you will get V of t. Once you get V of t, you can answer the later question. Right? They will just ask you to compute V of 0.1 or 0.05 or 0.02 or whatever. Okay, so for that you need to find V of t for any t. Okay. All right. So let's solve this question. And I think this is the final question I have. So that is first order linear ODE. Now this is second order constant coefficients linear ODE. Okay, so with initial conditions are also given to you. What you have to do is you have to find f of 2 and you also have to find f prime of 1. Okay, so for that, firstly you should solve the second order ODE and get f of x first. Okay, so find f of x first. Then we can find f of 2 or f prime of 1 or whatever. Right, so it takes some 3 to 4 minutes again. Okay, and if you are done, just let me know by providing answers in the chat or you just raise your hands. Okay, so anybody solve this? At least the first part. No? Okay. Shall I solve it or you guys are trying it? Okay. So take 2 more minutes. Try to get f of x. All right. So time's up. Let's solve this. Okay. So this is a second order linear ODE. Not only that, it's an homogeneous case. Right. So firstly, you have to write this in our general form. So once we write that in the general form, we will get this. So 4 f double prime of x minus 4 f prime of x plus f of x is equals to 0. Right. So you just have to multiply by 4, take that f of x to the left hand side. So you'll have this. After this, we assume that the solution is e power sx. Okay. So this is our assumption. So once we have this assumption and substitute, and finally we'll get this quadratic expression, which is 4s square minus 4s plus 1 to be 0. Right. So first we have to find the roots of this quadratic equation. If we find the roots, we will observe that s1 is, anybody? Half, right? And the second root will also be half, because this will be 2s minus 1 whole square. So 2s minus 1 whole square will have the same root repeated twice. So this is the second case where our roots are repeating, right? If our roots are repeating, then the general solution will be f of x is equals to c1 e power s1x plus c2 x into e power s1x, right? So here s1 and s2 are the same. Okay. So now once we have this, here s1 is half. So this will be c1 e power x by 2 plus c2 x into e power x by 2. The only things that you have to find now is c1 and c2. How do I find c1 and c2? I will use this information. F of 0 is 2. First I will use that. I will substitute x is equals to 0. I will have f of 0 is equals to c1 e power 0, which is 1, plus c2 into 0 into e power 0, right? So everything will become 0. You will have left hand side will become c1. Sorry, right hand side will become c1. The left hand side is f of 0. F of 0 is 2. Therefore, c1 is 2. Okay, so from there you will get c1. How do I get c2? I will take this derivate, not this, and derivate. I'll have, if I derivate the whole equation with respect to x, I will have f prime of x is equals to c1 into half e power x by 2, because the derivative of x by 2, e power x by 2 is half into e power x by 2, plus c2, here it is product of two functions x and e power x by 2. So I'll have c2 of, if I take the derivative, I'll have x and derivative of e power x by 2 plus x derivative, which is 1 e power x by 2. Right? Now I will substitute x is equals to 0. What will I get? F prime of 0 is equals to c1 into half into e power 0 by 2 plus c2, this is 0 anyway, half e power 0 by 2 plus 1 into e power 0 by 2. Okay, so this is 0 because you have a 0 getting multiplied. Right, so if I simplify, I'll have c1 by 2 plus c2 plus c2 whole into 0 plus 1, which is 1. So c1 by 2 plus c2 is f prime of 0, and f prime of 0 is 6. So I will substitute that. And also I will substitute c1 to be 2 because I got it from here. So this will be 6 is equals to 2 by 2 plus c2. From here c2 will be 5. Right, 6 minus 1 will be 5. So I got c1 and c2. The final solution will be solution is f of x is equals to c1 is 2. So 2 e power x by 2 plus 5x e power x by 2. So c2 is 5. So 5x e power x by 2. So this is f of x. Right. So once I know f of x, I can find f of 2. Right. I just have to substitute. So this is part 1. Substitute x is equals to 2. I'll have f of 2 is equals to 2 into e power 2 by 2 plus 5 into 2 into e power 2 by 2. So 2 by 2 is 1. So 2e plus 10e, which will give me 12e. Right. So where e also we know it is 2.71 approximately. So you substitute it 12 into 2.71 and get an approximate value for it. For second problem, what I have to do? I have to find f prime of x. Right. I know f of x is this. If I find f prime of x, it will be 2 into half e power x by 2 plus 5 whole into derivative of x into e power x by 2, which will be x half e power x by 2 plus 1 e power x by 2. Once I have f prime of x, I will substitute x is equals to 1 because I need f prime of 1, right? F prime of 1. So for that, I need to substitute x is equals to 1. I will have f prime of 1 to be 2 into half into e power 1 by 2 plus 5 of 1 into 1 by 2 into 1 by 2, 1 by 2 into e power 1 by 2 plus 1 into e power 1 by 2. Okay, so this and this will cancel. We'll have e power half plus 5 by 2 e power half plus 5 e power half. Right? You just have to add all these three. You will see that you will have 17 by 2 into e power half. Okay, so this also you can get an approximate value by substituting E as 2.7. Okay, but this is also the correct answer. 12e and 17 by 2 square root e. Okay, that is how you should solve this particular problem. All right, so I think I have discussed all the things that I wanted to discuss. If you have any doubt, you can ask me, or else I will get back to week 10 and try to answer Akhil's question. So if you have any doubts related to week 12, you can ask me. Or if you are okay, satisfied, you understood everything, then that's all I have for you guys today. Okay, so you can leave. Okay, thanks all. Akhil, you can just stay back. We will discuss the T bar IT thing, I theta thing. Okay, so rest of you can leave. Thanks all for joining, and we'll meet during revision sessions. Okay, so prepare well. This Sunday is the exam. Bye.